So today we are going to solve semester 2 section B questions, right, which were of 8 marks. There were 3 questions in all. Question were based on recursion, infix to prefix notation, and there was one question on binary tree. So let's take all the question one by one and try to solve all of them. First question of section B was, you need to write the difference between finite recursion and infinite recursion. Finite recursion, you can say, occurs when the recursion terminates after a finite number of recursive calls. A recursion terminates only when you have a base case or the base case is met. So to understand finite recursion, let's take one simple example, a method written using the recursive technique. Just look at this method. You'll find the name of the method is rec01, which takes one integer parameters, right? Then if the value of n is equal to 0, it will simply return, nothing will happen. That means this becomes the base condition. Otherwise, print the value of n with a space and again call itself with the new value of the n, that is n minus 1. So this is the recursive call, and you'll see each time it will reduce the value of n by 1, and one time the value of n will be 0. So can you predict the output of this method? If this method has been called and the number 5, the numeric number 5 has been passed as parameter or the value of n, you consider the value of n is 5 and just try to predict the output of this method. You can pause the video and just try to solve it. Yes, correct. The correct answer is 5, 4, 3, 2, 1. Every time the number is reduced by 1. If the initial value is 5, then the output is 5 space 4 space 3 space 2 space 1. But in different lines, right? Because instead of using print, we used println, so it will print the number every time in a new line. And similarly, you can define the infinite recursion. Infinite, you understand? If the recursive call will never end. So it occurs when the recursion does not terminate after a finite number of recursive calls, because the situation happens only if the base condition is never met. Look at the same example. The code is same except that we have made one small change in the statement. Look at the statement where we are calling rev01, or the recursion is happening. Instead of decreasing the value of n by 1, which we did in the previous example, we simply wrote n. So the value of n is not changing anywhere. If we'll take the same example and same value, say 5 is passed, you're calling this method and you pass 5 as a parameter for the value of n. So of course the value of n is not never changing, so the base condition will never met. So this method will run, this code will run infinite time. So such type of recursion is known as infinite recursion. I hope this is pretty clear with this example, right? Now let's take next question. Next question was, a expression is given and you need to convert the given expression from infix notation to prefix notation. I think you know infix means when you have operator in middle of the operands, and prefix means when you have the operator as a prefix, as a prefix. To solve such type of questions, you need to you should have the knowledge of something known as precedence level or precedence order of the operators, or there is a rule, there is a chart which explains the associativity of the operators. So let's take a look of that. So these are the list of operator normally we have in an expression, right? And this is the order of precedence. Precedence means who will be solved first. The parenthesis we need to solve first, then followed by the sign of exponential. Then these two operators, they are of same precedence, division or multiplication, then plus and minus. Then there is something called the rule of associativity, which says if you have multiple operators, then the operators are solved from left to right or right to left. Only in case of this operator, you need to solve right to left. Otherwise, for all the mathematical operators, the rule of associativity says you need to solve it from left to right. It means if you have two plus symbols, then first you need to solve the plus you have on the left side, sorry. So we'll keep this on right hand side for reference, and let's try to solve the given expression. So the given expression is an infix notation. You will find operator between two operands, right? Prefix means what? If we'll take the example of this expression a plus b, the prefix notation is just take out this operator before these operands. The plus ab is nothing but the prefix notation of a plus b. So look, let's take this expression p into q minus r plus s. So according to this chart, we need to resolve the parenthesis first. So we'll resolve q minus r. Q minus r will be written as operator, then operands, the minus qr. Rest everything will remain same in the second step. Then after solving parenthesis, we have the symbol of multiplication and addition. So we'll take multiplication first as per the chart. That means one of p will act as an operand and minus qr will act as other operand. So final expression is take out the operator, that is this asterisk symbol, then write the first operand, that is p, then write the second operand, that is minus qr. Then finally we have plus to resolve. Take out plus out first, then write the first operand, that is this part, and then you write the second operand, which is s, on the right side of the plus. So this is the final example, final answer, or you can say the prefix notation of given infix notation. I think this is pretty simple. So let's take another question. Third question in section B, or the last question in section B, is based on the binary tree. Binary tree, when we say binary tree, that means each node can have maximum at max two sub nodes. So a binary tree is given, and the first question says state the siblings of the nodes C and E, and also state the predecessors nodes and successor nodes of node B. So first we'll take the first part of first question. State the siblings of node C and E. Siblings, nodes with the same parents are normally known as siblings. If you'll say B and C belongs to same parent A, so B and C are siblings of siblings. Similarly, D and E belongs to same parents, so D and E are siblings. For this particular C node, there is only one child F, so F is alone. There's no other sibling for F, right? So look at the tree and you just try to predict the siblings for C. C is the node C, right? What are the siblings for C? The siblings for node C is not B, because B and C belongs to same parents. They are generated from same parents. And the sibling of node E is D. Again, D and E belongs to same parents. That's B. The second part says predecessors, or normally this is known as parent node. In a binary tree, any node except the root node has a unique node which is called the parent node. For node B, if you look at node B, there is a parent node which is called E, right? So for node B, the predecessor or the parent node is A, which is nothing but the root node. Similarly, if you look for the successor node or the child node, for the B, we have two successors, D and E, right? These are the two child nodes for B. So for node B, the successor nodes or the child nodes are D and E. This is how you can answer this particular question. Then the second part of this question was write the in-order traversal of left subtree and the pre-order traversal of right subtree. So in binary tree, to read the binary tree in the in order traversal of the format, there's a rule which says you need to read it like L plus R, means left, then root, then right. Right? If we talk about the in order traversal, that means the rule is says you need to read like left, root, and then right. So let's take the left subtree, which is not B, D, E, and F. This is the left subtree. And the in order traversal for this is D, B, G, E. The rule says left, root, and right. The first, if we'll take B as the root for this subtree, then leftmost node is D. So we wrote D. There's no other node to read on the left side. Then you need to write the root. Root के बाद if you go to right में you'll find the deepest left node is G, and then of course the parent is E. That way you can write the in order traversal for the left subtree. Now look at the pre-order traversal of the right subtree. Right subtree is this one, CFHI. To read the binary tree in the pre-order format, the rule says you need to first read the root, then left, then right. So according to that, root, then left, then right. So according to this, the pre-order traversal of the right tree is CFHI. And I hope this is useful for you. With this, we come to the end of section B. We'll take section C in the next video. Thank you so much for watching this video.